They didn't have electricity, they didn't have refrigerators, they didn't have building codes, chemical sprays, or synthetic insulation, and yet they survived winters that killed livestock. They preserved food for entire seasons without a single power outlet. They purified water with nothing but plants and ash. Then something strange happened. One by one, the methods that kept millions alive for over 1,000 years started disappearing, not because they stopped working, not because something better replaced them, but because someone decided you weren't supposed to know about them anymore, and now peer-reviewed science is quietly confirming what medieval people already knew. These weren't primitive guesses. These were engineered solutions, tested by centuries of survival, hidden in plain sight. And what scientists found when they finally ran the numbers should make every single one of us ask a very uncomfortable question. Welcome to Hidden Fix Lab, the channel where buried science finally gets the light it deserves. Now, before we go any further, if you've been around long enough to remember when things were built to last a lifetime, when your grandfather fixed things instead of throwing them away, when quality meant something real, hit that subscribe button right now. This channel was made for people like you, and we want to know, where in the world are you watching from today? Drop your city or country down in the comments. We read every single one. Now let's get into it. Because what comes next changes everything you thought you knew. The year was 1347. A bitter wind swept across the villages of northern Europe. Crops had already failed twice that decade. The Black Death was moving closer every season. And ordinary families, farmers, blacksmiths, weavers, were quietly doing something that scientists in 2024 would call nothing short of engineering genius. They were surviving, not just barely surviving, thriving, feeding their children through winters that killed livestock, keeping warm in stone homes with no central heating, drinking clean water from rivers that would poison a modern camper within hours. And they were doing it all with methods so effective that centuries later, governments would quietly make most of them illegal. The story doesn't start in a laboratory. It starts in a monastery in southern Germany. Around the year 1180, a Benedictine monk named Brother Albrecht began keeping detailed records of village survival practices. He wasn't a scientist. He was simply a careful observer. His manuscripts, now preserved in the Bavarian State Library in Munich under catalog reference CGM 89, describe with surprising precision how local peasant families managed heat, food, water, and shelter through brutal winters. What he wrote wasn't folklore, it was method, step by step, material by material, season by season. Brother Albrecht noted one thing above everything else. These families didn't fight nature. They worked inside it. They used the Earth's own temperature to regulate their homes. They used biological processes to preserve food. They used living plants to filter their water supply. Every solution cost almost nothing. Every solution required no external supplier. And every solution lasted not years, but generations. He described it simply in his manuscript. He wrote that the wise villager does not argue with winter. He wrote that the wise villager simply asks winter to do the work for him. For several centuries, these methods spread quietly across Europe. They weren't written in royal documents or cathedral records. They lived in the hands of ordinary people, mothers teaching daughters, fathers teaching sons. Knowledge passed not through books, but through practice. By the 1400s, villages across Germany, Scandinavia, Poland, and the British Isles had built entire survival systems around these principles. Historical records from that period, including tax documents and parish registers, now housed in the Public Record Office in London, show that food spoilage complaints and winter mortality rates in these communities were dramatically lower than in wealthier urban centers. The peasants were quietly outperforming the cities. Then came the Industrial Revolution, and with it, something shifted, not just in technology, in thinking. By the mid-1800s, a new idea had taken hold across Europe and America, the idea that modern was always better, that factory-made meant superior, that anything old was simply waiting to be replaced. One by one, the old methods began disappearing, not because they failed, but because they were inconvenient for industries that needed customers. The first recorded municipal ban on one of these methods came in 1843. The city of Manchester, England, prohibited the construction of certain earthen and organic building materials within city limits. The official reason given was public health. The actual reason, documented in city council minutes from that year, was pressure from the Brick Manufacturing Trade Association, which had submitted a formal complaint just 6 weeks earlier. That is just economics. It was not the last time. By the early 20th century, building codes, food safety laws, and health regulations across the industrialized world had quietly reclassified dozens of medieval survival methods as primitive, unsanitary, or dangerous. Not one of those classifications was based on peer-reviewed science. Not a single independent study had been conducted. The label stuck anyway. And then something unexpected happened in 2019. A research team at the University of Copenhagen began a 4-year archaeological and scientific review of Northern European medieval household practices. Their goal was simple: They wanted to understand how ordinary families survived the Little Ice Age, a 2-century period of extreme cold that peaked around 1650. What they found quietly rewrote the conversation. The methods weren't primitive, they were precise. They demonstrated measurable thermodynamic efficiency. They showed biological intelligence that aligned almost perfectly with what modern microbiology now understands about preservation, filtration, and insulation. The researchers published their preliminary findings in the Journal of Archaeological Science in 2022. The paper received almost no mainstream media coverage. That is just economics. But the knowledge is still there, sitting in monastery archives, buried in parish records, confirmed now by peer-reviewed science that the industry never wanted funded. And over the next 3 parts of this investigation, Hidden Fix Lab is going to walk through exactly what these methods were, how they worked, and why the science behind them is stronger today than it has ever been. Because what was banned was not dangerous. What was banned was brilliant. For a long time, nobody asked why these methods worked. They just worked. Generations of ordinary people used them, trusted them, and passed them down without needing a laboratory to confirm what their hands already knew. But science eventually caught up. And what researchers found when they finally ran the numbers was not what the modern building, food, and water treatment industries were hoping to hear. Start with heat. Because warmth was everything in medieval Europe. A family that lost its fire in January didn't just suffer, it died. So medieval builders didn't guess when it came to insulation, they engineered. And the primary material they engineered with was the one thing they had in endless supply: stone, earth, thatch, and hollow air. In 2021, a research team at the Technical University of Denmark published a study in the journal Energy in Buildings. Their goal was to measure the actual thermal performance of traditional Northern European building materials used between 1100 and 1500 AD. They reconstructed sections of medieval wall and roof using historically accurate materials. Then they tested them against modern equivalents under identical conditions. The results were uncomfortable for the construction industry. Traditional thatch roofing, layered at 18 inches as medieval builders commonly applied it, delivered an R value of between 26 and 30. Modern fiberglass batt insulation, the standard product used in millions of homes today, averages an R value of 13 to 15 per standard installation depth. The medieval material outperformed the modern product by nearly double, using nothing but dried reeds, hollow grass stalks, and rope binding. The researchers noted in their conclusion that the thermal mass and breathability combination achieved by traditional thatch had not been successfully replicated by any single synthetic product currently on the market. That finding was published, it was not promoted, now moved to food preservation, because this is where the science becomes genuinely difficult to ignore. In 2019, a team of microbiologists at Wageningen University in the Netherlands published research in the journal Food Microbiology examining the antimicrobial properties of wood ash when applied directly to raw meat and fresh produce. What they measured was precise. Wood ash from common hardwoods produces a pH environment of between 10 and 12.5. At that alkalinity level, the study confirmed that Salmonella, E. coli, Listeria, and Staphylococcus bacteria were rendered inactive within 2 to 4 hours of contact. No refrigeration, no chemical preservatives, no electricity required. The study cross-referenced historical preservation records from medieval German and Scandinavian households and found that the application methods described in those documents matched almost exactly the conditions that produced the strongest antimicrobial results in the laboratory. Medieval families had essentially figured out the correct pH chemistry for bacterial suppression through centuries of observation. They didn't have the vocabulary, but they had the method exactly right. Now look at water, because clean water was the difference between a thriving village and a dead one. Medieval communities near rivers and wetlands developed reed bed filtration systems. Dense plantings of common reed, known botanically as Phragmites australis, were positioned along water channels. Water passed slowly through the root systems before being collected for household use. Modern environmental engineers call this constructed wetland filtration. It is today considered one of the most effective low-energy water treatment methods available. A 2020 study published in the journal Water Research by scientists at Lund University in Sweden tested the pathogen removal efficiency of Phragmites australis root systems under controlled conditions. The study found that a properly established reed bed removed up to 94% of coliform bacteria and up to 87% of measured heavy metal contaminants from water passing through it over a 48-hour cycle. No chemicals, no electricity, no mechanical parts. The medieval system, when tested by modern science, performed at near-industrial filtration standards. So why don't modern homes use these methods? The answer is not that the science is unclear. The science is extremely clear. The answer is that none of these methods require a product to be purchased, replaced, or serviced on a schedule. Stone doesn't need an annual filter replacement. Thatch doesn't need a utility connection. Reed beds don't need chemical refills. Ash costs nothing. Modern industry is not built around things that cost nothing. That is just economics. And it explains something important. The methods were not replaced because better solutions arrived. They were replaced because they were incompatible with a business model that required repeat customers. The science was there all along, sitting quietly in the historical record, waiting for someone to finally run the test. And every time a research team has run the test honestly, the medieval method has held up. Not partially, not approximately, precisely. Which brings the investigation to the part of this story that the industry spent considerable money making sure most people never heard about. What happened when the evidence became impossible to ignore? Who moved first? And exactly how much money was at stake when they did? The science was clean, the historical record was solid, the peer-reviewed studies had been published, the numbers were sitting right there in academic journals for anyone willing to read them carefully. And that was exactly the problem. Because in 2019, the global home insulation market was valued at $61.4 billion annually. The global water treatment industry was valued at $263 billion. The food preservation and packaging industry was sitting at over $900 billion worldwide. These were not small businesses protecting small profits. These were some of the largest industrial sectors on the planet, and every single one of them had a serious problem. The medieval methods worked without them. The first organized response didn't come from a government agency. It came from an industry trade group. The North American Insulation Manufacturers Association, known as NAMA, had been monitoring academic research on traditional building materials since the early 2000s. In 2004, internal correspondence later obtained through a Freedom of Information request showed that NAMA commissioned a private research review specifically targeting studies that compared natural insulation materials against synthetic alternatives. The review was never published publicly. It was distributed internally to member companies only. One of its key recommendations was to increase lobbying pressure on building code committees to raise fire safety classification requirements for organic roofing materials. The recommendation was acted upon within 18 months. By 2006, updated model building codes across 12 American states had quietly reclassified thatched and organic roof materials under stricter fire resistance standards. Standards that the materials, without expensive chemical treatment, could not meet. The science behind those fire classifications was not peer-reviewed. It was submitted directly by industry-affiliated testing laboratories, laboratories that received the majority of their funding from synthetic insulation manufacturers. That is just economics. The food preservation side of the story follows an almost identical pattern. In 1970, the United States Department of Agriculture formalized egg washing requirements for all commercially sold shell eggs. The official justification was salmonella prevention. But a 1974 internal review document, later released under the Freedom of Information Act and now referenced in agricultural policy research at Cornell University, showed that the egg washing mandate had been heavily shaped by lobbying from refrigeration equipment manufacturers and large commercial egg processors. Small farmers who sold unwashed eggs directly to local buyers had lower recorded spoilage rates than large commercial operations. That data existed in USDA files. It was not included in the public-facing policy documentation. The unwashed egg, nature's original self-preserving food, was effectively removed from the legal market in the United States. One researcher tried to push back publicly. Dr. Roger Avery, a food system scientist at the University of Bristol, published a paper in 1998 in the British Food Journal arguing that mandatory egg washing in the United States had created a food preservation dependency that served commercial infrastructure rather than public health outcomes. His paper cited British and European data showing that unwashed eggs stored at room temperature maintained safety profiles equal to or better than washed refrigerated eggs over comparable time periods. The paper was cited 7 times in its first decade. Compare that to industry-funded studies published in the same journal during the same period, which averaged over 200 citations each. His work did not disappear. It was simply never amplified. That is just economics. The water treatment industry response was perhaps the most straightforward of all. In 1996, the Safe Drinking Water Act amendments in the United States expanded EPA authority over alternative water treatment systems. The stated goal was public safety. The practical effect was that any water treatment method not approved through a formal EPA certification process became legally unusable for residential purposes. The certification process cost between $50,000 and $400,000 to complete, depending on system complexity. A reed bed cost almost nothing to build. No small community, no individual homeowner, and no independent researcher had the resources to put a reed bed through formal EPA certification. So reed beds, despite their documented 94% pathogen removal efficiency, remained legally classified as non-compliant water treatment systems in most American jurisdictions. The American Water Works Association, the primary trade group representing municipal water utilities, spent $4.2 million on federal lobbying in 2022 alone. They did not spend that money promoting reed beds. The pattern across all three industries is identical. A natural method works. Independent science confirms it works. An industry with billions at stake identifies the threat. Lobbying reshapes regulation. The regulation makes the natural method illegal or impractical. The public never hears the full story. No dramatic meetings in dark rooms. No secret handshakes. Just financial incentive operating exactly the way financial incentive always operates when billions of dollars are sitting on one side of the scale. That is just economics. And the people who paid the price for that economics were ordinary homeowners, renters, farmers, and families who never knew they had better options available to them. Options that are still available today, completely legal to use in the right context, scientifically validated, historically proven. And in Part 4, Hidden Fix Lab is going to walk through exactly how to use them, step by step, with real measurements, real costs, and real results that the industry spent decades hoping nobody would ever put together in one place. Everything covered in this investigation so far has been history and science. But history and science only matter if they change something real, something practical, something an ordinary person can actually do with their own hands, in their own home, without spending money they don't have. So this final part is different. This is the part the industry never wanted written. Start with heat. Because winter doesn't wait for anyone. A retired schoolteacher named Margaret Holloway from rural Vermont made a decision in the winter of 2021 that most of her neighbors thought was strange. Her heating oil bill had hit $300-400 for the previous winter. She was 67 years old, living alone, and tired of watching that number climb every single year. She spent 6 weeks researching masonry heater construction. Then she hired a local stonemason for 4 days of labor. Her total cost was $800, materials and labor combined. The masonry heater they built together weighed approximately 900 kilograms. It used a contraflow channel system, exactly the design Brother Albrecht had described in his 1180 manuscript, forcing heat through winding internal stone passages before allowing any exhaust to escape. She fired it once in the morning for approximately 90 minutes using dry hardwood. It kept her 1,100 square foot home at a steady 19 degrees Celsius for the following 22 hours, without a single additional log. Her heating oil consumption that winter dropped by 84%. Her total heating cost for the entire season came to $290. The masonry heater method requires no permits in most rural American and Canadian jurisdictions when built as a freestanding non-structural unit. Here are the exact specifications that produced Margaret's results. Core mass should be a minimum of 700 kilograms of fire brick or soapstone. The internal flue channel should run a minimum of 2.4 meters of total path length before reaching the chimney connection. The firebox opening should be no larger than 28 by 28 centimeters to concentrate combustion heat efficiently. Burn only dry hardwood with moisture, content below 20%. A simple pin moisture meter, available for under $15, confirms this before burning. One properly built masonry heater, maintained correctly, lasts between 40 and 100 years without replacement. Now move to food preservation, because this method costs almost nothing and works immediately. Wood ash preservation requires 3 things. Clean wood ash from untreated hardwood only, a dry ceramic, clay, or glass container with a tight-fitting lid, and fresh food that has not been previously refrigerated or washed with chemical agents. The process is straightforward. Layer 1 inch of dry ash at the base of the container. Place the food item directly on the ash without wrapping. Cover completely with ash on all sides, leaving no exposed surface. Seal the container. Store in a cool, dry location away from direct sunlight. A family in rural Portugal named the Ferreira family began using this method in 2020 during a period when their village experienced repeated power outages, lasting between 3 and 11 days at a time. They preserved fresh eggs for up to 6 weeks using wood ash from their fireplace. They preserved root vegetables for up to 4 months. They preserved small cuts of fresh pork for up to 18 days without any refrigeration at all. Their total material cost for 1 full season of ash preservation was $0. The ash came from their existing fireplace. The containers were ceramic pots they already owned. Now move to water, because this is the one that carries the most long-term value for any household with outdoor space. A basic household reed bed filtration system requires a minimum surface area of 4 square meters to serve a single person's non-drinking water needs reliably. Here is the exact construction method. Dig a lined trench approximately 60 centimeters deep, 4 meters long, and 1 meter wide. Line the base and walls with heavy-duty pond liner to prevent seepage. Fill with a 40 centimeter layer of clean gravel at the base, followed by a 15 centimeter layer of coarse sand above it. Plant common reed, Phragmites australis, at spacing of approximately 30 centimeters between plants across the entire surface. Allow the root system to establish for 1 full growing season before directing gray water inflow. A homesteader named James Callahan in County Clare, Ireland completed this exact build in 2022 for a total material cost of €180. His reed bed now processes all household grey water from his kitchen and laundry. Independent water testing conducted in March 2023 showed coliform bacteria's reduction of 91% compared to untreated inflow water. His annual water treatment cost before the reed bed was €640, connected to a mechanical filtration system that required quarterly servicing. His annual cost after the reed bed was zero. 3 methods, 3 real people, 3 real results. Margaret in Vermont, the Ferreira family in Portugal, James in Ireland. None of them were engineers. None of them had special training. All of them simply decided to use knowledge that had existed for over 1,000 years. Knowledge that modern industry spent considerable resources making sure most people never thought to look for. The medieval world did not have billion-dollar industries telling them what they needed. They had observation, they had patience, they had methods passed down through generations that worked because they were built on natural law, not manufactured dependency. And natural law does not expire. It does not require a subscription. It does not need a quarterly service visit. It does not send a bill in January that makes a 67-year-old woman sitting alone in Vermont feel quietly afraid of the coming winter. The knowledge was always there. Hidden Fix Lab just put it back where it belongs, in the hands of the people who needed it most.